Dear students, welcome to the third session of our Chapter 5 Surface Chemistry. Today, we will deal with the topic colloids and its properties. A colloid is a heterogeneous system in which one substance is dispersed in another substance, called dispersion medium, and the size of the dispersed phase is from 1 nanometer to 1000 nanometer. So, where we have learned this word colloids? When we learned the chapter solution, we know that solution can be of three types: true solution, suspension, colloid. Right? And in this definition, we have explained about the dispersed phase and dispersion medium. Actually, it is what the solute and the solvent. Here, the solute and solvents are replaced by dispersed phase and dispersion medium. Which is the solute? Dispersed phase, and solvent is dispersion medium. So, solute dissolved in solvent, we are getting a solution. So, it is named as a colloid depending upon the nature. Now, there are three types of colloids. That is, if the colloid is like a solid in liquid means one of the dispersed phase is solid and the other one is dispersion medium, then we name that type of colloids as SOL, SOLS. If it is liquid in solids, that means liquid is the dispersed phase and solid is the dispersion medium, then we name it as gel. And if both the dispersed phase and dispersion medium are in liquid, then we name it as emulsion. So these are the three classification how the dispersed phase and dispersion medium are there. Okay, let's now compare the properties of these three solutions, that is true solution, suspension and colloidal solution. Taking the property nature, we know that true solution is homogeneous, whereas suspension and colloidal solutions are heterogeneous. But even though the colloidal solution sometimes appear as what? Homogeneous, but actually it is heterogeneous itself. So we can say that suspension and colloidal solution both are heterogeneous. Now when we take the particle size, true solutions particle size are less than 1 nanometer, and suspension it is greater than 100 nanometer. Colloidal solution, when it is taken, it is between the values 1 nanometer to 1000 nanometer. And if we talk about the sedimentation, the true solution do not settle. Why? Because it is completely soluble in each other. It is miscible. So, or it is, we can't see the particles. So, how we can say it is having some sediment? So, it is not having any sediment. Suspension, it settles on standing. And colloidal solution do not settle, because there also it's just moving here and there in the full solution, so we can't understand the particles are there or the heavier particles are there or not. So it is not settled, or there's no sedimentation. Diffusion, when we take, we know the word diffusion means completely miscible in each other or mixed with each other without doing any force or applying any force. So true solution is what? Diffuse quickly. Suspension, unable to diffuse because it settles after some time. And colloidal solutions diffuse slowly. Of course, that's why we are not getting the sediment there. Now, what about the visibility? We know that if the solution is homogeneous, then the particles are invisible. We can't see any particle there. What about the suspension? The particles are visible by our naked eye, or under microscope also it is visible. But what about the colloidal solution? The particles scatter light and can be observed under ultra microscope. Filtrability, the property when we take true solution, it can pass easily through animal membrane and filter paper because there is no particles, or we can't see any particles, no sedimentation is there. So the water or the true solution will pass easily through the animal membrane and filter paper. Suspension, it is unable to pass through the animal membrane, right? Colloidal solution, it pass through filter paper but not through animal membrane. This is the important thing there. It doesn't pass through the animal membrane. Now what about the appearance? When it is homogeneous, we know the solution will be clear and transparent. We can see the sides or whatever inside it is there, we can clearly see it. So it is transparent. Suspension is opaque. And what about colloidal solution? It is translucent. So these are the properties or the comparison of the properties between the true solution, suspension and colloidal solution, which we have learned before. We will see the classification of colloids. Based on some of the criteria, the colloids are classified as three. First one is the physical state of dispersed phase and dispersion medium. How it is classified? The first criteria is the dispersed phase physical state and the dispersion medium's physical state. That means whether it is solid or liquid, we have to see, and according to that we are classifying the colloids as solid, gel or emulsions. Then second one is according to the nature of interaction between the dispersed phase and the dispersion medium. How is the interaction between the dispersed phase and the dispersion medium? According to that, it is classified, and it is of two types, lyophobic and lyophilic. And the third classification is based on the type of particles of the dispersed phase. The type of particles of the dispersed phase, and it is classified into three, that is multi-molecular, macromolecular and associated colloids. Like that, three types it is classified. Now let's see the first classification, which is based on the physical state of dispersed phase and dispersion medium. So first we will see how we can define a dispersed phase. The material which is present in very fine state of aggregation is called the dispersed phase. I'll repeat, the material which is present in very fine state of aggregation is called the dispersed phase. If we are giving an example of a colloidal solution of sulfur in water, if this colloidal solution we are taking, in this which is the dispersed phase and which is the dispersion medium? Sulfur in water. That means sulfur will be acting as the dispersed phase. And what about the water? It will be acting as the dispersion medium. So next we have the dispersion medium's definition. That is the continuous medium in which the particles of the dispersed phase are distributed. The continuous medium in which the particles of the dispersed phase are distributed are called dispersion medium. The same example if we are taking for the colloidal solution of sulfur in water, which is acting as the dispersion medium, the water will be acting as the dispersion medium. The possible 8 types of colloidal systems are, when we see the dispersed phase dispersion medium, we are giving here the type of colloid plus the example in this table. So first we will discuss about the solid, that is dispersed phase and dispersion medium, both are solids. Then we can say it as what? Solid soul itself, because it's both in the same medium and solid form. And the examples are like colored glasses, gemstones, etc. If dispersion medium is solid and dispersed phase is solid and dispersion medium is liquid, then we can name it as SOL. S-O-L. It's a colloid itself. And the examples are paint, cell fluids, etc. Dispersed phase, if it is solid and the medium is gas, then we can name it as aerosol or sol itself. Then like examples smoke, dust and all. Dispersed phase is liquid and the dispersion medium is solid, then we will name it as gel, cheese butter, jellies, etc. Liquid and liquid, both the dispersed phase and dispersion medium both are liquid, means it is named as emulsion, like milk, hair cream, etc. Then next possibility is the dispersed phase is liquid and dispersion medium is gas. Then we can name it as again aerosol. Why? Because dispersion medium is gas. It's like fog, mist, cloud, insecticide sprays, etc. Now the next one is dispersed phase is gas and dispersion medium is solid. It can again said to be solid salt, like pumic stone, foam rubber, etc. Dispersed phase is gas, dispersion medium is liquid, then we can name it as foam, like froth, whipped cream, soap lather and all. So these all are the examples of the possible 8 colloidal systems, and the examples are here. So with this we can explain, or we can understand, that whatever thing we are taking, which phase and which medium it belong. With the physical state we can give them the name sol, gel, or emulsion. Now, depending upon the nature of the dispersion medium, the corresponding solutions are given some specific name, which is not coming under that one, that table. That is, like colloidal solutions in water, we can generally name it as hydrosols. Hydro means water, so hydrosols. And we can give them the other name, aquasol. Aqua means also water. If the colloidal solution is in alcohol, then we can name it as alcosols. If the colloidal solutions are in benzene, then we can name it as benzosols. And the last one is, the colloidal solutions in air are named as aerosol. So the colloidal solution which is in which medium we have to see. If it is water, hydrosol. If it is alcohol, alkosol. Benzene, benzosol. Air, aerosol. So like this we can also give the colloidal solutions the names as these. Next, second type of classification is based on the nature of interaction between the dispersed phase and the dispersion medium. So the first one is lyophilic colloids, and the other name of that one we can give it as solvent loving. Lyophilic means solvent loving. The colloidal system in which the particles of the dispersed phase have a strong affinity for the dispersion medium are called lyophilic sols. That means it will be having, that is, a dispersed phase will be having a strong affinity for the dispersion medium. And these colloids can be prepared by simply mixing of dispersion phase into the dispersion medium. So you just simply mix it, it will be easily becoming a colloidal system. It is self-stabilizing, a reversible source also, like gum, gelatin, starch, albumin in water. These all are the examples for lyophilic colloids or sols. The next one is the lyophobic colloids. And the other name for that one we can give it as solvent hating colloids or solvent hating sols. The colloidal system in which the particles of the dispersed phase have no or very little interaction with the dispersion medium are called lyophobic sols. So the main difference between these two colloids are, one is having a affinity towards the dispersion medium and the other one is having, we can say, very little or there is no interaction between the dispersed phase and the dispersion medium. So like this, colloidal systems are named as lyophobic sols, and these cannot be prepared by simply mixing of dispersed phase into the dispersion medium. Simply we can't make it. Now it needs what? Stabilizing. It needs stabilizing to preserve them. It is irreversible, and some of the examples are like colloidal solutions of gold, silver, ferric oxide, arsenic sulfide, etc. are the examples for lyophobic colloids. The third type of the classification is based on the type of particles of the dispersed phase. And the first one is multimolecular colloids. Now, on dissolution, a large number of atoms or molecules of a substance aggregate together to form the species having the size of colloidal range. So, on dissolution, if the number of atoms and all the molecules will be of the size of a colloidal range, then the species formed are known as multimolecular colloids. And these atoms and molecules are held together by weak van der Waals force. And the example for multimolecular colloids are gold sol, sulfur sol. Sulfur, of course, you can know that sulfur S8 it consists of, or sulfur 8 atoms are together and consisting what? The sulfur sol. So this is a multimolecular colloid. The second type of this type of colloid is macromolecular colloids. Macro itself, giant meaning comes. So macromolecules in suitable solvents form solutions in which the size of the macromolecules may be in the colloidal range, and such systems are called macromolecular colloids. And these are quite stable and resemble true solutions in many aspects. Some of the naturally occurring macromolecules are starch, cellulose, proteins, enzymes, etc. And those of man-made macromolecules are polythene, nylon, polystyrene, synthetic rubber, etc. So these are giant molecules, or we can say these are polymers. Now the third one is associated colloids. Some substances in low concentration behaves as normal strong electrolyte, but at higher concentration exhibit colloidal behavior due to the formation of aggregates. The aggregated particles are known as micelles and are also known as associated colloids. So this we were learning in the soaps and detergents part. In grade 10 we have learned the cleansing action of soap and detergents, and the same micelle formation is there. So it is named as which type of colloid? Associated colloid. The aggregate particles are said to be associated colloids. And the structure is given like this. We know the hydrophobic and hydrophilic part is there in soap or detergent. And here the tail is there. The head part is having what? COO minus charge. And this is alkyl part. The formation of micelles takes place only above a particular temperature, which we are naming it as Kraft temperature or TK. Kraft temperature means above the temperature the micelle formation is there. A particular temperature is there. That temperature is known as Kraft temperature. And above a particular concentration of electrolyte is said to be the critical micelle concentration. So above a particular concentration of the electrolyte, it is named as CMC. Now let us compare the three colloids, that is multimolecular, macromolecular and associated colloids. So first one, in multimolecular colloids, how it is formed? Formed by the aggregation of large number of atoms or molecules with diameters less than 1 nanometer. Macromolecular colloids, they are formed by the large size molecules. Associated colloids formed by the aggregation of large number of ions in concentrated solution. So this is the difference between the formation of these three colloids. Next one, about the nature, that is lyophilic or lyophobic. Multimolecular colloids are lyophilic in nature, that is solvent loving. Macromolecular solids are macromolecular colloids are lyophobic in nature, that is solvent hating. Associated colloids are acting as both lyophilic and lyophobic they are. Then coming to the molecular mass. Molecular mass is intermediate in the case of multimolecular colloids, but it is very high in macro and associated molecules. Then weak van der Waals force is held in the multimolecular colloids, or these particles or atoms are held together by weak van der Waals force. On the other hand, these are held by stronger van der Waals forces due to the long chains of the polymer or whatever the macromolecule is there. And associated colloids van der Waals force increases with increase in concentration. According to the concentration, we can say how the force is there. Now let's see how we can prepare the colloids. The first method is chemical method. Colloidal dispersions can be prepared by chemical reactions leading to the formation of the molecules by the four methods, that is double decomposition, oxidation, reduction, hydrolysis. And the molecules then aggregate leading to the formation of what colloids are salts. Let's see some example with the equation. That is arsenic oxide is converted to arsenic sulfide, which is a salt, by double decomposition. So how is the equation or the reaction? As2O3 plus 3H2S gives As2S3 plus 3H2O. The next one is sulfur dioxide is converted to sulfur sol. The oxidation process is done here. That is SO2 plus 2H2S gives 3S plus 2H2O. Then gold or silver can be prepared. That is gold sol or silver sol can be prepared by the reduction method. So it is 2AuCl3 plus 3HCHO plus 3H2O gives 2Au sol, gold sol plus 3HCOOH plus 6HCl. The last one is hydrolysis. That is ferric chloride is converted to ferric hydroxide sol. So how it is done? FeCl3 plus 3H2O gives FeOH thrice plus 3HCl. And these four equations you have to learn by heart so that you can write the chemical method for the preparation of colloid when it is coming. So it is very important also. So learn it properly. The next method is electrical disintegration or Briggs arc method. Here you can see there's a diagram where we are having a beaker or a container, and in that ice water is kept. Inside the ice water, a beaker is there which is having dispersion medium or the solvent is there. In that beaker we have kept two electrodes which is connected to the cell. Now how this method is working? An electric arc is struck between the electrodes of the metal immersed in the dispersion medium, and then the intense heat produced vaporizes the metal, which then condense to form the particles of colloidal size. This way we can get the sol or the colloid. So the thing is, you should keep the beaker which is having the dispersion medium in a ice bath, so that the intense heat produced by the vapors of the metal condenses to form the particles of colloids. So this is what said to be Briggs arc method. Because of this, arc is struck between the electrodes. It is named as Briggs arc method. And the last method is peptization. Peptization may be defined as the process of converting a precipitate into colloidal sol. That is, it is a process to convert a precipitate into colloidal sol by shaking it with a dispersion medium in the presence of small amount of electrolyte. So, if the precipitate is converted into colloidal sol by the presence or by the amount of a small electrolyte, we can name it as peptization. And the electrolyte which is used for this purpose is known as peptizing agent. During this peptization, the precipitate adsorbs one of the ions of the electrolyte on its surface, and this causes the development of positive or either negative charge on the precipitate, which ultimately breaks up into smaller particles of the size of a colloid. And this part we will learn like a charge on the colloidal particles. So how is the charge coming? When the peptization process is there, the precipitate adsorbs any one of the ion from the electrolyte, and then it causes a charge on the precipitate. That is, either it is positive or negative. So the smaller particles of the size of the colloid breaks up. Thank you, and we will continue in the next session.